Alright, this video is to help with the performance task assignment. The performance task assignment has two challenges, and both challenges are to create a model. If you need review on creating a model, all you gotta do is review slide 30 on how to make a model, and it gives you 6 different methods to make the best model you possibly can. And you've had practice with this, so you just need a little review, of course, look at that. Alright, this is the assignment. The first page of the performance task says make sure you follow the instructions on each slide, and there's 2 other slides. It says each slide requires a model, as we talked about, to show your understanding of the challenge. For model challenge number 1, you need to design a model that shows, so you need to make a model that shows, or that includes Earth and 2 other planets. Now, it doesn't matter what 2 other planets you choose, but you need to choose Earth and kind of create a model that compares Earth to 2 other planets. And you're comparing them based on their gravitational force. So your model will show Earth and 2 other planets, and you'll create a model or a drawing that shows how they have the same or different gravitational forces from one another. And you'll use those guidelines on how to make a good model from the brain primer to make the best visual or drawing model that you can to show basically how gravity is different on those 2 other planets from Earth. In order to kind of decide which planets have more gravity or less, there's a link, and let me show you that. It's this link right here, Planetary Fact Sheet. So in your effort to complete model challenge number 1, you need to use this link right here. You click here, and the important thing is to focus on Earth. You can click on Earth and it'll give you a little information on that, but what we really want to do is just go back and know Earth, and it gives measurements for all these planets, including our moon. It gives information on mass, diameter, density, gravity, all of this stuff, down to surface pressure, and much more. There's a lot of data in this table. However, all we need to focus on is gravity. So it's this column right here. So you're just going to focus on this, this row. Now, Earth and everything else in there has numbers that may look interesting. Earth is 1 no matter what on here, and that's because this whole table is comparing other planets and the moon to Earth. And the way this was done mathematically results in Earth being 1, and all other values, if they're less than 1 for a planet, it has less mass, and if the number is greater than 1, it would have more mass than Earth. Same for gravity. Gravity on Earth would be 1 based on the math that makes this data table. But look, is there anything greater than 1? Jupiter. Jupiter's number is 2.36, but Earth is 1. That means Jupiter has a higher value for gravity than Earth. So go along with that thinking. And then we have many planets that have less than 1. Mercury, for example, has 0.378. That means Mercury's gravity is less than Earth because Earth is 1 and 0.378 is less than 1. That means Mercury's gravity is less than Earth. So the gravity on Mercury really wouldn't pull on an object on its surface as much as you would find on Earth. And then you can go across here and find if there are planets that have more gravitational force or less compared to Earth. But if that value is above 1, that's telling you what the gravity is like, stronger or lesser compared to Earth. And if that value is less than 1, it's telling you if their gravitational force is more or less than Earth. So anything above 1, gravitational force would either be stronger or weaker. You decide what you think that would be. If you need help deciding mass plays a strong role too. So things with greater mass than Earth would be more than 1. So anything that has a value above 1, such as Jupiter here, Jupiter has much more mass than Earth. Earth is 1, Jupiter is 317. That means Jupiter has a much greater mass than Earth. So use that same line of thinking for gravity. So you have to pick 2 other planets. So you pick Earth and pick 2 other planets and use the values they have compared to the values for Earth to decide and to show in a drawing that the gravity is more or less than Earth. And that's model challenge number 1. So let's revisit that really quickly. Model challenge number 1 is you need to create a model that shows how planets have more or less gravitational force than Earth, and you're using the data table data right here, using any of these planets here and the gravity values to show visually in your drawing, creating this model of how 2 planets have more or less than Earth. You can also use the moon. It doesn't have to be, it's just 2 other planetary bodies. If it's the moon, that's fine, or some of the other planets. Alright. Alright, your next model challenge, and it's the final one, is you need to design a model that shows our solar system. So you need to find a Google image or draw from your own memory a solar system picture. Don't make it super detailed, because the important information that you're going to draw is not going to be how perfect looking the solar system is, but some of the other information based on gravity. Okay, so in your solar system, you want to draw and show your understanding of the gravitational force. You want to show the gravitational force between each planet and the sun. That means your drawing or image, your model, needs to show some attraction the sun has with each planet. But what you want to do is, in this model that you're designing, the model that you're drawing, you want to show if the sun has equal gravitational pull on each of the planets. And how are you going to decide if that's true or not? How are you going to decide if the sun pulls on Jupiter more or less than, say, Earth? Well, the idea is to go to this PhET Gravity Force Lab, and you've reviewed this before, and to explore this to decide if you think Jupiter or Earth or any of those planets would have more or less gravitational force based on distance. So does distance matter? Does distance change how much gravity affects the sun and another planet? So further planets from the sun, like say Uranus, is Uranus experiencing a higher gravitational pull from the sun or a lower gravitational pull from the sun? Is Mercury, it's closer to the sun, is it experiencing higher gravitational pull from the sun or lower? The only way you can kind of figure out if distance matters is to go to this site, right? We have it right here. And you're going to basically change the distance between objects. I'm not going to do it. I want you to discover this on your own. But you've done this activity before. But I want you to change the distance between objects and see if that increases or reduces or has no effect on the gravitational force. And that's this value here. It's in newtons. That's the gravitational force, right? These numbers right now are small. But you have to decide, does the number increase, decrease, or stay the same based on how far apart they are? You may wonder, well, when I draw the solar system, how will I know which planet is further or not? Just make sure you find a picture that shows which planets are the furthest, which ones are closer. Get the order right. And then in creating your model, you need to show if you think the sun is pulling more or less on each of those planets, or the same amount on all of them, based on what you learned in this website. And again, this link is made available on the 330 assignment right here. That's the link, Gravity Force Lab. An advanced task that would get you extra points on the assignment is your ability to also try to predict with your drawing, your model, showing how mass, not just distance, but mass may or may not play a role in the gravity pull between the sun and a planet. So does mass have a role to play as well as distance? And the only way you can think of that is, well, you can play with the mass of different objects on the simulator. You can change the mass of this object or this to try to reflect what the mass differences might be of planets. Now this is a little advanced, but if you want to really challenge yourself and make a model that shows not only the expected forces between Sun and other planets based on distance, but of also mass, this would raise your grade just based on your effort. I want you to try this. If you need to create a third model to show how mass may affect the gravitational pull between the Sun and other planets, that's fine. If you want to draw and show how distance and mass affect gravitational pull between the Sun and other planets in a single model, that's also fine. It'll just be a little more complex. I draw the picture a little bigger. If you're wanting to know which planets have more or less mass than the Earth, well then you can always go to the table and you can see this mass here. You can see some planets have less mass than Earth. Earth is 1 here, right? Remember, anything less than 1 would be a lower mass than Earth, and anything with a higher than 1 value is going to be greater mass. And then you can compare that to what you find here when you change masses. When you change masses here, is it affecting gravity? Ultimately, you need to focus on basic things. Your model should show your best understanding of the events. It should be your first draft effort. It needs to show a process or action, cause and effect. The cause and effect in this would be the effect of gravity on other objects. And your model needs to have words and symbols. Probably the best way to show gravitational force would be to use arrows, but you can do it any way you like. But make sure that your drawing, your model, makes it clear that the Sun has gravitational pull or force on planets, and you need to make sure your model shows it as the same amount of force or different based on your understanding of distance between objects and how gravity might be impacted by the mass of each object. All right, good luck.